Hello and welcome to my channel. In this video, we are going to solve the first 5 questions from CBSE Class X Examination 2022-23. Section A, that is multiple choice questions where each question is of 1 mark. The first question is from the polynomials chapter. The graph of y equal to p of x is given for a polynomial p of x. The number of zeros of p of x from the graph is. Now we have to know that the number of zeros means the number of times the curve touches or crosses the x-axis. Now here we can clearly see that the curve touches the x-axis just once. So the number of zeros of p of x is going to be 1. So the option is B. Now let us move on to the second question. Now this question is from pair of linear equations in 2 variables chapter. The value of k for which the pair of equations kx equal to y plus 2 and 6x equal to 2y plus 3 has infinitely many solutions is. Now we have to find out the value of k which satisfies infinitely many solutions. Now infinitely many solutions is nothing but coincident lines. So let us write down the condition for coincident lines. Now the coincident lines or infinitely many solutions, the condition is a1 over a2, that is the coefficient of x for the 2 lines, should be equal to b1 over b2, that is coefficient of y, is equal to c1 over c2, that is the constant of the 2 lines. Now a1 over a2, a1 is the coefficient of x for the first line, which is k, over a2 is going to be 6, is equal to, now let us see what is the coefficient of y. So for the first line the coefficient is 1, over, for the second line it is going to be 2, should be equal to c1, that is constant of first line is 2 and the constant of the second line is 3. Now let us see if there exists any value of k that satisfies 1 over 2 is equal to 2 over 3. Now here if we look at the options, the k value is given as 3, negative 3 or 4. So let us take it as 3 over 6 first. So 3 over 6 is equal to 1 over 2. So it satisfies b1 over b2. But it fails to satisfy c1 over c2 because this is not equal to 2 over 3. So this is not going to be our answer. Let us check with negative 3. So if it is negative 3, then it is not going to satisfy b1 over b2 because it has to be negative 1 over 2. So this is not satisfied. Since one condition is not satisfied, it is not going to be c as well. Now the third one is going to be 4. So let us check if this is going to be satisfied. So 4 over 6 is going to satisfy 2 over 3, but it is not going to satisfy b1 over b2. So this is also the wrong option. So the value of k that satisfies b1 over b2 as well as c1 over c2 does not exist. So B is our answer for this question. Now there is a second approach to solve this question. You don't have to substitute the value of k in this equation one by one. So if you want to save time, directly in the second step when you substitute the values of a1, a2, b1, b2 and c1, c2, you can clearly see that 1 over 2 cannot be equal to 2 over 3 because these two fractions are already in the most simplified way. Since these two conditions are already not equal to each other, there cannot exist any value of k that satisfies these two conditions. So immediately you can mark the answer as B. So you can use either the first method or this method. Now let us move on to the third question. Now the third question is from the arithmetic progressions chapter. If p minus 1, p plus 1 and 2p plus 3 are in arithmetic progression, then the value of p is. Now since these are 3 numbers or 3 terms in arithmetic progression, their common difference have to be same. That is, for example, compare this sequence with the given one, that is 3, 5 and 7. Now if you look at this sequence, the common difference is going to be 5 minus 3, that is 2, and the common difference between third term and second term is also going to be 2. So you can see that the common difference is same. Similarly, we are going to find out the common difference between these two, and that will be equal to the common difference between these two. So let me write here. So we have written here the second term, which is p plus 1 minus the first term p minus 1 is equal to the third term, that is 2p plus 3 minus the second term, which is p plus 1. Now let us just simplify this by expanding the brackets. So we get here p plus 1, and then minus multiplies with the bracket, so minus times p gives us minus p, and minus times minus 1 gives us plus 1, is equal to 2p plus 3, and minus times p gives us minus p, and minus times plus 1 gives us minus 1. Now on the left hand side, the plus p and minus p add together to give us 0. So let us cancel it out. So 1 plus 1 gives us 2, is equal to, let us gather the like terms, that is 2p minus p gives us p, and 3 minus 1 gives us plus 2. Now taking plus 2 on the other side of the equal to sign, we get p is equal to 2 plus becomes minus 2. So here 2 minus 2 gives us 0. So the value of p in this AP is 0. So the option is C. Let us move on to the fourth question. Now the fourth question is from the coordinate geometry chapter. In what ratio does the x-axis divide the line segment joining the points a3, 6 and b, negative 12, negative 3? So let us understand this question by using a rough figure first. So here I have drawn a x-axis line, and there are 2 points, that is A and B, as given in the question, that cuts the x-axis at point M. I have considered this point as M. So here the coordinates of A I have considered as x1, y1, and the coordinates of B as x2, y2. Now if you look here, this line AB cuts the x-axis at point M, and the coordinates of M I have considered as x, 0. Since it cuts the x-axis, the y coordinate is obviously going to be 0. And x coordinate we do not know, that is at what point AB cuts the x-axis. So the coordinates are x, 0. And here the section AM is taken as the ratio M1, and the section MB is considered as ratio M2. And from the figure we can clearly see that we have to make use of section formula to find out the value of M1 is to M2. So the formula is mx, y, that is this coordinate, is equal to m1 x2 plus m2 x1 over m1 plus m2, and the same thing repeats but with y coordinates, that is m1 y2 plus m2 y1 over m1 plus m2. Now here we have to just plug in the values of x1, x2, y1 and y2 respectively to get the values of m1 and m2. So here x1 is going to be 3, y1 is 6, x2 is negative 12 and y2 is negative 3. So let me plug in here. So here the coordinates of M are also being substituted, that is M x, y coordinate is 0, and m1 times negative 12 plus m2 times 3 over m1 plus m2, and m1 times negative 3 plus m2 times 6 over m1 plus m2. Now let us further simplify this. So we get negative 12 m1 plus 3 m2 over m1 plus m2, negative 3 m1 plus 6 m2 over m1 plus m2. Now to find out the ratio of m1 and m2, you can either equate the x coordinates or the y coordinates. Now the easier option is to equate the y coordinates from both the sides. So we can write minus 3 m1 plus 6 m2 over m1 plus m2 is equal to 0. Now the denominator goes on the other side and multiplies with 0. So the denominator goes down to 0. And we are left with negative 3 m1 plus 6 m2 equal to 0. Now taking plus 6 m2 on the other side of the equal to sign, we get negative 3 m1 is equal to plus 6 m2 becomes minus 6 m2. Now we are going to take the m2 on the other side of the equal to sign and the negative 3 on the right hand side. So we can write here m1 over m2 is equal to negative 6 gets divided by negative 3. Now here the negative and negative sign cancels each other. So we are left with 3 1 times and 3 2 times. So the ratio is going to be m1 is to m2. So m1 is to m2 is equal to, now 2 over 1, this fraction changes into a ratio, that is 2 is to 1. So this is the ratio in which the x-axis divides the line segment. So let us see if it is in the option 2 is to 1. So it is option D. Now let us move on to the fifth question. Now the fifth question is from the circles chapter. In the given figure, PQ is a tangent to the circle centered at point O. If angle AOB is 95 degree, then the measure of angle ABQ will be. So we have to find out what is the measure of the small angle ABQ. So let us consider the triangle AOB first. Now in this triangle, OA and OB are the radius of the circle. So side OA of this triangle is equal to side OB. So this represents an isosceles triangle. So let us consider that the angle A, that is OAB, is angle X, and angle OBA also will be X. Using the angle sum property of a triangle, we can write angle X plus angle X plus angle 95 will be equal to 180 degree. Now X plus X gives us 2X, and taking 95 on the other side we get, so 2X is equal to 180 minus 95. Simplifying this, we get 2X equal to 85 degree, or we can write X equal to 85 divided by 2, which is equal to 42.5. So the value of X is 42.5 degree. That is the small angle. Now we have to make use of a circle theorem, which is known as a radius tangent theorem. Remember that the tangent always makes a 90 degree angle with the radius it touches. So here OB is the radius and PQ is the tangent passing through it. So the total angle, that is angle OBQ, is going to be 90 degree. So out of that 90 degree, we found that this small angle X was 42.5. So angle ABQ, the remaining angle, is going to be 90 degree minus 42.5. So let me write here. Angle OBQ is equal to 90 degree, that is because of radius tangent theorem. And angle ABQ is equal to angle OBQ, this 90 degree angle, minus angle OBA, that is angle X, which we had got. So angle OBQ is 90 degree minus OBA was X, which we got it as 42.5. So the difference between these two angles will give us a value of 47.5. So this is the value of the angle ABQ. So here our option is option A. This is our answer. I hope you have understood all the steps and liked the video. If you know any other way of solving these examples, do comment below. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.